All right, so we are going to talk about statistical significance. The section in our book is a little bit longer, but basically it's statistical significance. So, to see why probability is so important in statistics, imagine that you're trying to test whether a coin is fair. That is, whether it is equally likely to land on heads or tails. So, a set of measurements or observations in a statistical study is said to be statistically significant if it is unlikely to have occurred by chance. So that means it occurred because of a particular thing and not just by chance. So, our example one, we have a researcher who conducted a study that's a double-blind experiment that tests whether a new herbal formula is effective in preventing colds during a 3-month period. The 100 randomly selected people in a treatment group take the herbal formula, while the 100 randomly selected people in a control group take a placebo. The results show that 30 people in the treatment group get colds compared with 32 people in the control group. Can we conclude that the herbal formula is effective in preventing colds? All right, so if we're looking at this, we got to talk about a couple of things in here. First of all, whether or not a person gets a cold during any 3-month period depends on a lot of unpredictable factors. You know, it just depends on what's going on. It's not just about an herbal thing, right? It depends on what you're around. You know, is it because there's a bunch of allergies in the air? Is it because you're around somebody else who has it? There's a lot of factors. So we should not expect the number of people with colds in any two groups of 100 people to be exactly the same. And in this case, the difference between 30 people and 32 people who got the colds in the treatment group versus the control group, it's not small enough to be explainable by chance. So, I mean, the comparison of 30 to 32 is awfully close. So saying that the difference is not statistically significant, we should not conclude that the treatment is effective. Because you have 100 people in the control group that got a placebo and 100 people in the treatment group. Well, 30 and 32 of them got colds. Well, that's so close that you can't say the herb was effective because the number of 30 and 32 of the people, it's just too close. Now, if you had maybe 2 people in the treatment group and 32 people in the control group, then you might be like, okay, so maybe we need to look at this a little bit more. I would also say that their samples are not that big, right? So this would not be statistically significant. So let's write a few words here so you have a little bit. So we are in 6.1, if you're in my class. For example 1, not statistically significant. Significant. All right. And part of that is you have 30 in the treatment group, 30 from the treatment group, and 32 from the control group. These are who got colds, okay? So they got colds. That's too close in number. So that is not statistically significant. All right, and you could even take like 30 out of 100 and 32 out of 100 and do some of the comparison because you had 100 in each one to see what the percentage is, and you'll find that those percentages are really close. So you could even do a little bit of math there. All right, next question. Example 2. So in the test of the Salk polio vaccine, remember we've talked about this a couple of times. 33 of the 200,000 children in the treatment group got paralytic polio, while 115 of the 200,000 in the control group got paralytic polio. So if we do a precise calculation by researchers showed that the probability of this difference between the groups occurred by chance was point, lots of zeros. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros and then a 2, or 8 zeros, 2%. So it's really, really small. So was this result statistically significant? Well, in this case, it would be statistically significant at the 0.05 level, which means if there was less than 5% likelihood of them occurring by random chance, and significant at the 0.01 level if there was less than a 1% likelihood of them occurring by random chance. But because this actual probability of them occurring by chance was calculated to be so small, it's going to be significant at both of those. So that's why the researchers were so confident. So you're like, okay, you said a lot of things. Let's write some of this out. So at the 5% level, which is 0.05, it would be statistically significant. So in I can spell, can't. I'm just going to have struggles with this. I'm just going to finish it out. Significant. I want to do the A instead of the other. So sorry. And then also at the 1% level, which is 0.01, it was also statistically significant. There we go. All right. Now, the reason is because we end up with a 0.2%. Well, that's definitely a number that is way smaller than 0.01 or 0.00 or 0.05. So that's where it's going to be at both levels. So this is going to make it statistically significant at both levels. And because of that, they were like, oh, we need to, this vaccine is working because of what they figured out. All right, and those 0.05 and 0.01 levels, those are just common levels that they use in statistics, saying at this level, blah, blah, blah. All right, does it make sense? Results from a study of heart disease have statistical significance because heart disease is such an important health risk for adults. All right, so example 3. We want to know, does that make sense? So let's read it again. Results from a study of heart disease have statistical significance because heart disease is such an important health risk for adults. Well, it doesn't make it statistically significant just because it's an important topic. It has to have that statistical significance by the results, not just because it's an important thing. So this does not make sense. So just because it's an important topic, so remember, because the probability, statistical significance has a particular meaning with regard to the probability that the results occurred by chance, and it doesn't. It doesn't mean that it's a topic is important. So So just because, I'm trying to figure out how I want to say this. So just because the topic is important does not mean it is statistically, there we go. I was trying to figure out on the last one, like, what was I missing? It's just statistically significant. Yay, we spelled them both right. There's just a lot of letters, and you're trying to talk at the same time. It just makes it kind of crazy. All right. So, does it make sense? In a clinical trial of treatment for reducing back pain, the difference between the treatment group and the control group, which received no treatment, was found to be statistically significant. This means that the treatment will definitely ease back pain for everyone. So they're saying that the treatment was statistically significant. So that showed that it was working. The statement that follows is, this means that the treatment will definitely ease back pain for everyone. Does that make sense? Well, let's talk about that. It says it works for reducing back pain, but there's a lot of different types of back pain, right? So does it do it for all back pain? Does it do it for some back pain? It doesn't mean that it's going to ease the back pain for everyone, okay? All right, so example 4, again, does not make sense. So at any level of statistical significance, there's always some probability that the result is incorrect. Okay, so it also is stating that I would say that just because it worked for some does not make it says for everyone, right? Doesn't mean it's going to work for everyone, because there's different types of back pain, like I said. So it doesn't mean that it's going to just work for everybody. So just be aware of that. All right. Doesn't mean it's going to work. And it could be incorrect. So you just got to see how it works and what comes into play. All right. We are, this is 6.1, so make sure you do your homework and continue to stay on top of everything that we are doing in the class.